All right, let's dive right in. Today we're talking about behavioral design patterns. Now, if that sounds a little academic, just think of them as a collection of brilliant, proven solutions to the kind of problems that pop up all the time when we're trying to build software.
You know that feeling, right? That little bit of déjà vu when you're deep in your code and you think, wait a second, I'm pretty sure I've solved this exact kind of communication problem on 3 other projects. It happens to all of us.
And this quote it hits the nail on the head. Design patterns are all about not reinventing the wheel. They give us a shared vocabulary and a toolkit of reliable, reusable solutions that have been tested in the real world.
Specifically, we're zooming in on behavioral patterns. This is all about how objects talk to each other, how they collaborate and how responsibilities get divided up. Think of them as the rules of the road for how your objects interact, keeping everything flowing smoothly.
Okay, first up, let's talk about a pattern that I can almost guarantee you've used, even if you didn't call it by its official name. It's the iterator, and it tackles a super common task, working with collections of things.
So here's the situation. You've got a list, maybe an array, some kind of collection of data. You need to loop through it, one item at a time. The trick is you want to do that without the code that's doing the looping needing to know how that collection is built on the inside. Why? Well, it keeps your code clean and flexible.
And the answer is the iterator pattern. Now, if you've ever worked with relational databases, this is going to sound really familiar. It's basically a database cursor. That cursor lets you step through the results of a query, one row at a time, and you don't have to worry about how the database actually stored or fetched that info. The iterator does the exact same thing for your objects.
And at its core, it's incredibly simple. The iterator really only has to answer 2 fundamental questions. First, hey, is there another item for me to look at? That's the hasNext method. And if the answer is yes, then the second question is, awesome, give it to me. And that's the next method. That's it. It completely separates the how to loop from the what you're looping through.
All right, our next pattern, the observer, solves a very different kind of problem. This isn't about pulling data out of a collection. It's about an object needing to push updates to other objects whenever its own state changes.
This is a classic scenario, right? You've got some central piece of data. When that data changes, a whole bunch of other parts of your application need to react. Maybe the UI needs to update, a log needs to be written, a cache needs to be refreshed. How do you coordinate all that without turning your code into a tangled web of dependencies?
The best way to think about this is a subscription model. It's just like subscribing to a podcast. The podcast host, the publisher, doesn't need to know every single listener personally. They just publish a new episode, and every single person who subscribed automatically gets a notification. Simple, clean, and efficient. So you've got 2 key players here. You have the subject, that's our publisher, the object with the important state, and then you have the observers. Those are all the subscribers who are interested in hearing about any changes. This creates a really clean, one-to-many relationship. Now there is a key choice to make here. How do those notifications work? You could use a push model, where the subject sends out all the juicy details about the change in the notification itself. Or you could use a pull model, where the subject just sends a quick heads up like, hey, something's different, and it's up to each observer to then ask for the specific information it actually needs. Okay, on to our third and final behavioral pattern for today, the strategy pattern. This one is all about making your algorithms flexible and interchangeable. So imagine this. You have an object that needs to do something, maybe sort some data or run a calculation, but the exact way it should do that can change. You might need different sorting methods or different calculation rules depending on the situation. How do you manage that without writing a gigantic, messy if-else statement?
A perfect real-world example is calculating taxes. The general idea is the same. You have an entity, and you need to calculate the tax it owes. But the actual formula, the strategy, is totally different for an individual person, a big corporation, or a nonprofit. You need to be able to just plug in the correct formula when you need it.
And that is precisely what the strategy pattern lets us do. We define a whole family of algorithms. We take each one, the individual tax calculation, the corporate one, and we wrap it up. We encapsulate it in its own separate strategy object. As long as they all follow the same basic rules, they become totally interchangeable. It's like having different tool bits for the same power drill.
And the real magic here is that the main client code stays super clean. It just picks the right strategy and tells it to go. It doesn't need to know the messy details inside. This makes your system incredibly flexible. If the government adds a new tax rule for, say, partnerships, you just create a new strategy class. You don't have to change any of the existing code. That's huge.
So there you have it. We've just explored 3 really powerful patterns to add to your software design toolkit.
Let's do a super quick review to make sure these ideas stick.
So let's lock this in. If you need to walk through a collection without getting bogged down in its internal details, you reach for an iterator. If you've got one object that needs to broadcast updates to many others, that's a job for the observer. And if you need to make algorithms swappable at runtime, you encapsulate them using the strategy pattern.
But maybe the single biggest benefit of all of this is that it gives us a shared vocabulary. When you can walk into a design meeting and say, hey, let's use a strategy pattern here, everyone on the team instantly knows what you mean. It makes talking about complex ideas so much clearer and faster.
So as you head back to your own code, think about this. Where do you have some tangled notification logic that could be an observer? Where are you looping through things in a way that could be simplified with an iterator? Or where do you have a big conditional block that's just screaming to be refactored into a set of strategies? These patterns aren't just theory, they're ready to solve your problems today.
And that wraps up our look at these behavioral patterns. I really hope this explainer was helpful. If it was, we'd love it if you'd like, share, and subscribe for more. Thanks for watching, and we'll catch you on the next one.